Welcome back to this tutorial on how to create a game that looks like Fall Guys. Last time we created the project, so today we will see how to create a third-person blueprint. We'll create our own blueprint. I will show you how does it work. We will also create some animation, so I will show you where to get the animation and the animation that we will use. So let's dive into it. So first of all, we will start by deleting everything that we have created last time. So we will delete the third person folder, we'll force delete, we delete the level prototyping, and we delete the character. Up. So we wait a little bit. During that time, we will go on a website called Mixamo. In this website, we can see that there is some character and some animation. For the character, I created my own with Blender. It's a very simple mesh that we will use for our game. And we will get the animation from Mixamo. I created a package and I put it in the description. You can actually download it. You will have the mesh and all the animation that we will use during this project. So we can see there is a lot of different animation. We have some dancing animation. We have some weird animation. We have some death animation, and so on and so on. And we can import our own character. We can upload the character and then choose the animation for that character. So it's what I did. If you want a video, a tutorial on how to use our own mesh and how to convert from Mixamo to Unreal Engine, because we need to convert it with Blender, tell me in the comments and I will make you a little video. It will be like a 5-minute video on how to import properly your character, because you can take it like that and just put it in Unreal, it will work. And for the root motion especially, it will not work. So if you want to have this little tutorial, tell me in the comment and I will do it. We will go back to Unreal, everything is deleted. If you can still see a package like that, just right click on comment on the content folder and click Fix up Redirector. And then we can delete it. And if it still doesn't want to go away, we will show in Explorer and I will delete it itself. Here we are. So the folder is out. So we'll create two new folders. We'll create a first folder called Blueprints and we will create another folder called Mesh. We'll go in the mesh folder, we will create another folder called player. So in here we'll have our player mesh. So we'll click on import. And here we can see that there is the bunny.fbx. This is our mesh. So we'll open this. We will leave everything as it is. We don't have to change anything. Just this import animation, we will uncheck this because we don't have the animation with the mesh. The animation are on different folder. They are on different file. We'll click import all. So wait a little bit and our mesh is gonna appear in here. So here is our mesh. We can see. So we can see that there is different folder. We have the material, which is the different material that we use in the mesh. We have the white color, which is the body, and the black color, which is the eyes and the nose. And we can see three different files in here. We have the skeletal mesh. This, if we go there, we have the skeleton, which is our bones. We have the root, the hips, the legs, the spine. And then on the last file is the physics asset. So we can see that our physics asset is a little bit weird. We will fix it later because we will need to add some physics. Just to show you the physics, what does it do? If I click on simulate, you can see that our bunny fall is like a ragdoll. And if I do this, I can actually grab him and make him roll around. But we will use that later to make a ragdoll. I will show you how to do that thing and we will fix it up because the physics asset is not good. So we can close everything. And we will go in our blueprint folder. We will right click and create a new folder. Call this player. And in this player folder, we will create blueprint class. and the parent class will be the character. So a character is a type of pawn that includes the ability to walk around. Exactly what we want. So this BP, this player character, we can double click and we can see in the viewport some stuff that are already there. We have the capsule, we have the mesh. In the mesh, we will put our bunny. We will click on the skeletal mesh asset and we will choose the bunny. And we will have to place it. We will go down, we will rotate it. Little bit backward. I can click here to change the perspective. So on the left, I will put it there. I will click on the capsule and I will change the height of the capsule. It's a little bit too big. I will change the radius. Now it looks good. Okay, it will do for now. We'll compile and save. I will go back into the perspective. So we'll add a spring arm for our camera. So I will click on the capsule component and I will click press add. And I will choose the spring arm. We can see the red line, it's our spring arm. We will lift it up a little bit, maybe put it a little bit behind. And at the end, on the spring arm, we will add a camera. Put 0 and 0 to our camera. So it's actually connected to our spring arm. So the spring arm, it's something that will try to keep the camera always at the same place. And if something gets between the spring arm, it will put the camera closer. Like if there is a wall here and our camera is supposed to be behind, it will actually go in the front. That's it for our little character. And now we will need to create some input because we will use the enhance player input. It's the new feature of Unreal for the inputs. So we'll create a folder inputs in our player. We will open this and we create another folder called input action. So to use the new input system, we will go into input and we will choose the input action. For this loop before our mouse, and we will create another one for the move. In the looks, we need to change this to axis 2D. So we put axis 2D in the input action look and save and close. And in the move, and for the move, we will change the value type also to the axis 2D. Save and close. And now we have both our input action. Now we'll go to the inputs folder and we will right click in the input called, we will choose the input mapping context. Call this YMC underscore player input. We will create one mapping. We will choose the move. So to go forward, we will use the W. In W, we will add, for the W, we will add a modifier. It will be the swivel input axis value. Close this, we will add another key with the S to go backward. And here we will add two modifiers, the swivel input value axis value, and the negate, because we want to go backward. Then we need to go left and right. So to go left will be the A. For this one, we will just put the negate, just need negate. And for the last one, for the last key, with the D, we will put nothing. save, we can close this, and we will create a new mapping for the look. So one, and this is gonna be the mouse. We can go in the mouse, and we will choose the mouse X, Y, D axis. And we will add a modifier, we will add the negate. We'll save and close. And now we can go in our blueprint player character, and we will go into the event graph, and we will create, we'll add some code. We will delete all of this, and we will start by using the begin play. Use the event begin play. This event will trigger at the beginning of the game, so when we start the game, or when this blueprint appear in the game, the begin play will launch, and everything that is after will work. So in the begin play, we will start by getting the controller, because we need to set up to tell him to use our input system that we just created. We will get the controller, we will cast to the player controller. We will get in here the enhance this, the enhance input local player subsystem. And from this, we will check if this is valid. So this is the good one, it's not the one with the function, it's the interrogation point. So if the enhance input local player subsystem exists, is valid. If it is valid, we will choose this, and we will add a mapping context, connect to the isValid, and in the mapping context, we will use our player input. We'll compile and save, and now we can use all the input action that we have created. So if I right click and I type input action underscore, we can see our events. So we have the look and the move. We'll start with the look. So every time that it is triggered, we will add some movement. We'll add controller yo input, and we will do add controller pitch input. So we choose the controller yo input and the pitch input. In the action value, because it's a 2D vector, we will right click and split the struct spin. So we can have the X and the Y. We'll put the X in the yo and the Y in the pitch. Compile and save this. We can actually click this little arrow, close it up so that it's a little bit more clean. And we will choose the move, input action move. We'll do the same, we will split this action value in. And for the trigger as well, we will add some movement input. We'll add movement input. For this movement input, it will be the left and right. So we will actually get our controller rotation. So we want to know in which rotation our character is, so that when we press the left, it actually go on the left, whatever the rotation of a character is. We get the control rotation of the pawn. We will right click in this and split. And we will call a function called get right vector. This one. We'll split this as well. And we put the X and Z. We can use this in the world direction. And the scale value will be the action value X. So now we can go left and right, and we will do the same for the forward. So we'll add a movement input. Now we'll have to get the forward vector. So we'll get our control rotation. We'll call a function called get forward vector. We'll split this pin and we'll give him the z-axis. So in the world direction, and it will be the y action value. We can compile and save. Now we will add some little commands to make it a little bit cleaner. So we just drag and drop to choose all of our little box. you will press C to add a comment, and we will change this to camera movement. We'll take this, press C, this player movement, and if you want, you can also just take a little piece on this tree, press C. We'll have to make it a little bit wider. So I can change the name of this one, and for example, put right, left, right, left, right movement. Or left, right movement. And do the same with this one. Press C, forward, backward movement. Okay, so that's good for our player character. We just need to change some stuff. First, we will test it, and I will show you what is wrong. We'll go in our map, and we will need to create a game mode. So we will go in our maps folder, we'll right click, create a blueprint class, and it should be the game mode base. This GM testing map, we will double click, and in the class default, you can actually click on the class default in here. You can see all the different classes that are attached to this game mode, and in the player, the default point class, we will choose our blueprint player character that we just created. We compile and save. Now we need to use this game mode, so we will go in the edit project settings. In the maps and mode, we will choose our game mode testing map, and we have our default point class that get updated, and we use the player character. We can close this and now press start, and we have our character. So we have some weird stuff. I cannot really move the camera. The character is moving, but it is weird. So we will change some stuff. First, we will go in the spring arm, and we will check this use pawn control rotation. And now we can actually move in every direction. Now we will go in the blueprint player character, and we will type yawn, and we will disable this use controller rotation yawn. Okay. I just forgot something. There is something weird with the look. We need to go in the input, player input, and it's in the negate. We don't want to negate in every axis. We don't want to negate on all the axes, and we want to negate only on the y-axis. So we deselect X and Z, and we just leave it on Y. Now if I start the game, it's better. So we can see that there is still some weird stuff going on. We didn't finish to change all the stuff in the player character. In our character movement, we will scroll a little bit so we can change a lot of data in here. So we will go in the character movement rotation settings. We will change the rotation rate 600, and we will select orient rotation to movement. We'll compile and save, and now we can start the game. And now we have the character that moves perfectly as we wanted. Just one little thing, we will put the camera a little bit further away. So we will press spring arm, and in the target arm length, you can choose something like 450, 450. And now we are a little bit further away. And we just need now to add some animation to our little character. So we will go in the mesh mesh in the player, we will right click and create a new folder called animation. Create a folder called animation. In this animation folder, we will import. We can actually import all of them because we will need them one day. We need to leave skeletal mesh selected and we deselect import mesh. Now in the skeleton, we open this and we choose the bunny skeleton. We make sure that the animation is good. There is nothing to change. We import all. It will import all of our animation. And now we will go in the idle animation. So you can see, if I go to the first frame, with the conversion with Blender, we have a little issue with the first frame. We have the first frame on T-pose, so we want to start our animation from the first frame. So we will go a little bit down, and in the animation length, we will change this to set range. The frame import range will be from the first frame to the last one, which is 59. And we re-import the animation. And now the first frame is not a T-pose anymore. Everything is perfect. Then we will go in the walking animation. We will have the same issue. The first frame is a T-pose. We need to fix that. We'll go to set range and the minimum will be 1 and the maximum will be 31. We click re-import. Now it's good. And we will do the same for the running animation. Set range, minimum 1, maximum 19. And here we are, we have our animation, which is perfect. Now we'll go back to our animation folder. In the animation folder, we will create something called animation blueprint. We will choose the bunny skeleton, we will click on create. For this ABP, our animation blueprint bunny. And we will create in the animation on the legacy, we will choose blend space 1D. We choose our bunny skeleton, we call this BS for blend space, and this is for the walk and run. So we start with the blend space. The blend space, it's actually to blend between two animations with a value. The value, it's in the horizontal axis. We change this to speed. Minimum will be 0, maximum will be 400. We save, so it's updated. Here we have 400 and we have the speed. At 0, we will have the walking animation, and at 150 speed, we will have the running, and we put the running at the end. So if the speed is between 0 and 150, it will blend between the walking and the running, and at the end it will just be the running. So we save this. Then we go in our animation blueprint. In the animation blueprint, we can see an anim graph and an event graph. The event graph will be get all the variables that we need for our animation graph. First of all, we will go in the event graph. We will delete everything and we will call an event called a blueprint initialize animation. So when we start the animation, we want to get some reference. So we'll get phone owner. This one, it will be the file get phone owner. We'll cast this to character. Plug it in. Now we can get some function from the character. So we will actually promote this to variable. We just call this character. It should be the reference of the character that we can use some other place. And from this, we will get the character movement. So we type character movement, then we scroll down, and we will have this variable get character movement. And now we'll promote this to a variable. Up. Okay, so it's good for the initialization. Now we want to get some variable during the animation. So it will be with the event update animation. We get this one. We'll first of all check if the character is valid. You will get character and you will type is valid with the little question mark. Up. If the character is valid, that means we cast it to the character and we have everything, so we can use it. We'll use a sequence node. This sequence will actually do this, and then we'll do this, and we can add more pin and do multiple stuff without having a big line of nodes. You can separate them. First, we'll use the character movement. We'll get the velocity. Get the velocity, and we will save this. We promote to variable. We leave the name velocity, it's perfect. And we will do vector length xy. And we call this, we will promote this to variable and call this ground speed. Okay, perfect. Now for the second stuff that we will do, we will get the character movement, we will get the current acceleration, and we will see if there is actually some acceleration. So if the acceleration is different, is not equal to 0, that means we are actually moving. Just put an end boolean. So we want to check that the current acceleration is different than 0 and that we have actually some ground speed. So we will get our ground speed variable, put greater than 3, it should be our minimum value. Put these two, so if ground speed is more than 3 and the current acceleration is different than 0, then this will be true, and we will promote this to a variable, and we call this should move, like this. And we plug this to the then one. So we have all the variables that we need. Now we'll go in the anonym graph and we'll right click and create a state. So we type state and we go up to this state machine. We click, we will rename this, we will call this locomotion, because it should be the movement of our character. We open this, and the first node that we will put, it should be a state called idle, to build our idle animation. And we will go inside, we double click on the idle and we can go inside. Then we choose our idle animation, we plug this, and then we left click on idle and we will choose to have a loop animation. We'll select this loop animation. We compile and save. And now we'll use our blend space. So we have on the right the blend space walk run. We will take it. So we created a state called blend space walk run. It's perfect. We will create a transition by clicking in here and drag and drop to the other one. We will do the same to come back. So now we will be able to change from the idle animation to our blend space. And to do that, we have a transition, and this transition, in this, we will use the variable should move. So when should move is true, the state will go from the idle animation to the blend space walk run, and our character is gonna be running. Then we have to be able to, when we stop running, we have to go back to the idle. So we double click on this transition, we put the should move, and we do a not boolean. So if we are not moving, this is gonna be the inverse of the not, of the false. So if should move, so if should move is false, then this is gonna make it true. So when we don't move, we go back to the idle animation. We will just go in the blend space walk run because we need to add something. We can see our blend spaces here and we want some speed. So it's going to be the variable called ground speed. There we compile and save, and we will go back to our anim graph, and we just need to plug this in this one. We compile and save. Now we go back to the blueprint player character to actually use our animation blueprint. So we click on the mesh, and on the right on the animation, we can see the animation mode is use animation blueprint, and the anim class is set to none. We will open this and call the APB bunny. You can see that our character is now doing the idle animation. We compile and save, and if we start the game, it should be working. So we are in the idle animation, and if we run, we are actually running. So here we are, we have a character now with his own blueprint, with his own animation, and on the next episode we will do some root motion animation. So I will show you how to have an animation that can actually move your entire character. So we will do a roll animation, and it will be on the next episode. So if this episode helped you to create our own blueprint for your character and your animation, don't hesitate to drop a like. If you have any question, you can post a comment. I will try to reply to you, either with a video or in the comments directly. And don't forget to subscribe if you don't want to miss the next episode on the root motion. So I will see you on the next episode.